A couple more examples of solving systems by elimination. This time we have a fraction, or a couple fractions actually, throughout our equation. So we have 2x minus 3/4 y equals -3. I'm going to start by multiplying this first equation by 4. In the second equation, the common denominator between 9 and 3 is going to be 9. Okay, so I'll just start by rewriting this system. And if I multiply through 4 times 2, 8x, 4 times -3/4, -3y, 4 times -3, -12. 9 times x, 9x, 9 times a ninth, just y. And then finally, 9 times 13 thirds. Well, we get 9 times 13 divided by 3, right? And then that's going to simplify into 3 times 13, which will be 39. All right. Now, at this point, what we want to do is we want to try to eliminate, all right? And what we're going to do is we're going to cross multiply, if you would. So I'm going to multiply this equation by 8, okay? And I know the numbers are going to be big, but it's okay. We can use a calculator. And then up here, I'm going to multiply this equation by -9, okay? Just because I want to make sure one's a positive, one's a negative. And so our new system, -9 times 8 is going to be -72x. -9 times -3, 27y. And then -9 times 12, that should be positive 144, but I'm just going to check in my calculator. All right, so -9 times -12 should be, it's 108. Good thing I checked. Okay. So 108. And then 8 times 9, 72x, that's good. 8 times y, 8y. And then finally, 8 times 39, that's going to be the ugly one, but no big deal. We have a calculator that can help us out. So 8 times 39 is going to give us 312. All right. Now we're going to add the equations together. Okay, 72's cancel out. 27 and 8 gives us 35y. 108 and 12 gives us 420. Right? Now we're going to divide both sides by 35 to solve. Okay, that should be a 35, not a 38, or mostly a 38. All right, and so we can once again, where this 5 really doesn't want me to write it. Okay, and so we're just going to take our 420 divided by 35. Okay, and we get 12. Okay, so y is going to be equal to 12. Okay, now what we can do is we can substitute back into any of the equations. Okay, I'm just going to substitute it back in right here. Okay, again, it doesn't matter where we do it, it just matters that we do it. Okay, so I'm going to get that 9x plus 12 is going to be equal to 39. Okay, and if I subtract 12 from both sides, that gives me 9x is equal to 27. And clearly we can see that x is going to be 3. Okay, so that means we get the ordered pair 3 comma 12 as our solution. All right, so again, if we have any sort of fractions, what we need to do is clear those out by multiplying by a common denominator individually, okay? Not the common denominator of all the fractions, just common denominator of all fractions in equation 1, common denominator of all fractions in equation 2. All right, now we have decimals, okay? So what I always do is, to clear out the decimals, is I multiply by the number of decimal places. So notice that this is 100th, this is 100th, and this is 100th. So we have 200ths, 400ths, and 900ths. So I'm going to multiply everything in the first equation by 100, okay? And remember, multiplying by 100 moves the decimal point 2 places to the right. And if you don't trust me, you can always use the calculator. And so by multiplying through by 100, 2x plus 4y equals 9. I have 1/10, 3/10, and 8/10. And so what I'm going to do is multiply everything by 10. And so I get -1x plus 3y is equal to 8. Now I can use the elimination method. I'm going to multiply the first equation by 1, right, and the second equation by 2. Right? So just cross multiply if you would. Multiplying the first equation by 1 just keeps this first equation the same. So 2x plus 4y equals 9. Multiplying by 2 on the second equation, we get negative 2x plus 6y is going to be equal to 16. Those cancel out. We get that 10y equals 25. We divide by 10. And we get that y is equal to either 2.5 or we could just say 5 over 2. Okay, because they both contain a factor of 5. Now I'm going to substitute y back into either equation, okay? What I could do is I could substitute it right in here, okay? Again, it doesn't matter which one, all right, but it looks like this one's pretty easy to work with, no negative numbers, pretty small values for the coefficients. So we get 2x plus 4 times 5 halves is equal to 9. 4 times 5 halves is going to be 10. So 4 divided by 2 is 5. 4 divided by 2 is 2. 2 times 5 is 10. So 2x plus 10 equals 9. We're going to subtract 10 from both sides. So by subtracting 10, we get that 2x equals negative 1, and x is negative 1 half. And so our solution set is going to be the ordered pair negative 1 half, 5 halves. Okay. All right, so that's how we want to go through and try to take care of these sorts of equations that have fractions and decimals in it with the elimination method. All right, now the last thing we're going to take a look at in this section is application problems. Okay, and basically our problem solving method is we're going to read the problem, understand what's given, we're going to define our variables. The hardest part usually is creating the system of equations. Okay. Then we want to try to solve the system using any method we want. Okay. Usually elimination is probably going to be the easiest one. Make sure our answer makes sense. And then we just go back through and verify the solutions. Okay. What we might want to do is we might want to graph it at the very end. All right. So let's just solve a couple basic sorts of number problem equations. Okay. Then we can move on to other real world scenarios. So we have two numbers that say the sum of the two numbers is 10, the difference is negative 34. We want to find each number, okay? Whenever we see the word sum, that's plus, okay? Let's call x the first number. And surprisingly, let's call y the second number. All right, might as well because we don't have anything better to do. Okay, so y is going to be our second number. Okay, and so sum means plus, difference means minus. And so the sum of the first two numbers, x plus y, is equals 10. The difference, x minus y, is 34, negative. There we go. That's our system. Right? This is one of the easiest systems we could possibly get because notice that the y's are opposite. So we can add these together. So we're going to use our elimination method. They're immediately opposites. X plus x is 2x. 10 minus 34 is negative 24. We divide by 2. And so that yields that x is going to be negative 12. For the other number, let's just substitute in. Okay, so negative 12 plus y is 10. We're going to add 12 to both sides. And so the other number is 22. All right, and that makes sense. Okay. If I add negative 12 and 22, that gives me 10. If I subtract them, negative 12 minus 22, that's going to give me a negative 34. Okay, so that certainly makes sense. If we wanted to write it as an ordered pair, which we often do, all right, that would be the way that we write it. Okay. 3 times one number minus the second is 8. The sum of the numbers is 12. Find each number. Again, let's define x to be the first of the two numbers. Let's define y to be the second of the two numbers. 3 times one number, 3x, minus the second. Okay, so 3 times the first minus the second is 8. The sum of the numbers is 12. Okay, we already saw sum of the numbers is 12. Once again, this leads us really nicely to the elimination method. Okay, and not all of them are going to be this nice, but so far they are. Y's cancel out. 4x equals 20. X is going to be equal to 5 when we divide both sides by 4. Again, we're going to substitute. Let's substitute it into the easier of the two equations for the back substitution. We get 5 plus y is equal to 12. We subtract 5 from both sides, and we get y is equal to 7 as an ordered pair, 5 comma 7. Right? So really easy for us to be able to work on these sorts of applied problems, especially with the number types. Okay. Now we are going to look at some more of these in our final video where they're a little bit more difficult. Okay, but that's the premise of this, is being able to set them up by using this 5-step process. All right. And then going from there, we can use any of the methods that we choose. Most of the time, elimination is going to be the fastest way to do it. Okay. However, sometimes substitution might be appropriate, but graphing shouldn't be an option just because it's not as always accurate. Okay.